Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm your teacher, Dr. Sayyeda Manazia. This lecture is related to your lab, CHM 422 and 402, which is based on classical methods of analysis. This experiment is a part of gravimetric methods, and the title of your experiment is Determination of Fe+2 ferrous ion in the given sample solution. So here I will discuss the procedure of this experiment, and I will present the scheme which is actually showing all the steps of the procedure. So first of all, wash all the glassware with tap water and then rinse with distilled water. Now, take a large beaker. In this large beaker, you have to transfer 10.0 ml of sample solution. Sample solution will be provided to you on the side bench. So go there on the side bench and pipe it out 10.0 ml of the sample solution. So you have to transfer 10.0 ml of given sample solution of Fe+2 ferrous ion to a beaker with the help of a pipette. And then you have to add about 25 ml distilled water directly from the wash bottle and about 10 ml of dilute nitric acid, HNO3, with the help of a measuring cylinder. So now in this beaker, you have Fe+2 ferrous ion sample and distilled water and dilute nitric acid. So here, nitric acid, HNO3, is used as an oxidizing agent to convert Fe+2 ferrous ion into Fe+3 ferric ion. Now heat the content of the beaker until the solution present in the beaker turns yellow. Next step is to cool the content of the beaker up to room temperature. Then you have to add about 2 grams, which is actually 2 spatula of solid ammonium chloride NH4Cl and about 10 ml of aqueous ammonia NH3 solution with the help of a measuring cylinder to the content of the beaker slowly with constant stirring with the help of a glass rod. So here you can see that Fe+3 ferric ion present in the solution will react with the ammonia solution NH3 or NH4OH in the presence of ammonium chloride NH4Cl to form reddish brown precipitates of FeOH3, which is ferric hydroxide. Afterwards, you have to digest the reddish brown precipitates of FeOH3 ferric hydroxide along with mother liquor on steam bath or water bath for 15 minutes. Basically, mother liquor is the solution in which the precipitation reaction is carried out. So you have to heat the content of the beaker in water bath for about 15 minutes. And this process is called as digestion. So digestion is a process in quantitative analysis that refers to the coagulation of a precipitate into a filterable form. Then you have to cool the content of the beaker up to room temperature. Afterwards, you have to filter the reddish brown precipitates of FeOH3, which is ferric hydroxide, through Wortmann 41 filter paper. You have to collect all the reddish brown precipitates of FeOH3, ferric hydroxide, left in the beaker by adding about 10 ml portions of 2% ammonium nitrate NH4NO3 solution 3 times to the beaker and filter. So what you have to do here, you have to add 10 ml portions of ammonium nitrate NH4NO3 solution 3 times to the beaker and then filter. So this will help you to collect all the precipitates. Afterwards, you have to wash the precipitates of ferric hydroxide FeOH3 with about 10 ml of 2% ammonium nitrate NH4NO3 solution. Then you have to keep the funnel along with wet reddish brown precipitates of FeOH3, which is ferric hydroxide, in oven at 110 degrees centigrade for 1 hour for drying purpose. So this will absorb all the moisture present in the precipitates. Meanwhile, you have to take a washed and dried china crucible and you have to weigh it accurately up to 4 decimal places. Now, transfer the dried reddish brown precipitates of ferric hydroxide FeOH3 along with Whatman filter paper to the weighed china crucible. Then heat the china crucible on direct flame for charring until Whatman 41 filter paper burns completely. So this process is called as charring, which is actually partial combustion or burning. After charring, keep the china crucible along with precipitates of ferric hydroxide FeOH3 in furnace at 900 degrees centigrade for ignition of precipitates. So this process of ignition is also known as complete combustion. On ignition, ferric hydroxide FeOH3 is decomposed into ferric oxide, which is Fe2O3. Because on ignition, all metal hydroxides are decomposed into their respective oxides. So finally, after ignition, keep the china crucible in a desiccator to attain the room temperature. And after cooling up to room temperature, finally, you have to weigh the china crucible along with ash of Fe2O3, which is ferric oxide. This was all about the procedure of this experiment. Thank you very much.